reality is something objective. But in fact, everything you see around you exists only as you interpret it. Each person lives in their own version of the world, as if observing the vast universe through a keyhole. And the strangest thing is that none of us has ever seen the full picture. We know that somewhere out there is distant space, galaxies, endless structures. But all that is available to us is a tiny fragment of reality, which we don't even fully understand. And then a question arises that makes us uneasy. What if our universe isn't the only one?
The reality we observe every day is quite subjective. After all, each person interprets what they see in their own way. Unfortunately, only a tiny part of the universe is available for us to observe. Humans resemble rabbits in a maze. You can choose the direction to move, but seeing the whole picture is not an option for such a tiny and helpless observer. Priests and stargazers. In ancient times, priests were compared to celestial beings for a reason. After all, they understood the language of the sky and could decipher the whispers of distant stars. Even today, the profession of astronomer is respected because it is believed that these people observe the entire visible universe, and for them, almost nothing is hidden. But there are things in the world that inspire superstitious awe even in the most learned men. What can we say about ordinary people? For example, at first glance, the question may sound strange. How many universes does our universe contain? Come in. People are used to thinking that they live in a huge bubble filled with rows of galaxies, where stars shine dazzlingly like lanterns and planets endlessly revolve. All of this is true, but there is also another perspective on this topic. Realizing we aren't the center of the universe was a difficult journey. The geocentric system, which assumed that the Earth is the foundation and that other celestial bodies revolve around it, has long since faded into history. It was replaced by the heliocentric and then the galactocentric system. Modern humanity has realized that our metagalaxy does not have a center as such, and it holds many unsolved mysteries. It is possible that not just one, but hundreds of millions of universes coexist successfully next to us, all enclosed in a common network. But we are unable to see this, just like a rabbit in a maze. Philosophy is a science that wholeheartedly supports the multiverse theory. Many of its representatives believe that all probable life scenarios will inevitably be realized in one of the billions of worlds, since possibility and reality are closely interconnected. Simply put, if you couldn't bring yourself to go on a round-the-world trip in this universe, then in another one, you will definitely become the second Phileas Fogg. In one world, you are king, and in another, a slave. If here and now you are watching this video, then in another universe at this moment, you are flying on a plane, and in a third one, you are sleeping. In some reality, the worst possible scenarios come true, and in another, the best ones. And this does not contradict the universal laws. Judge for yourself, a coin can't land as both heads and tails at the same time. The theme of alternate realities has been creatively reimagined many times in various fairy tales and science fiction movies. The Wizard of Oz.
Дверь в стене Уэллса или экстравагантной ленте «Беги, Лола, беги». Подобные теории находят подтверждение и в квантовой физике. Хью Эверетт, знаменитый американский
The Wizard of the Land.
еще в 1950 году сформировал многомировую интерпретацию, согласно которой привычный нам мир на самом деле малая часть безграничного количества вселенных. Как возникли эти странные реальности? Общеизвестно. Начальной точкой зарождения нашей Вселенной стал момент Большого взрыва. Что было после этого, наверняка неизвестно. Теории разнятся. В частности, одна из гипотез гласит, что вследствие молниеносной первые секунды после взрыва Вселенная в буквальном смысле раздувалась, увеличиваясь в 10 в миллионной степени раз. Появившееся пространство, наполненное ложным вакуумом, порождало массу миров, включая наш, обладающих различными свойствами, физическими константами.
If we could look into one of these universes, this world would probably seem very strange to people. But considering the vast size of the titanic bubble of the multiverse, the borders of neighboring spherical domains are incredibly far from us. Perhaps the answer to the question of where the so-called brains, the walls of neighboring universes, are hiding lies in the mystery of dark matter. 95.5% respectively. According to many scientists, it is these undiscovered worlds that make up that very hidden mass. But the most interesting question is, what are they like, these neighboring universes? What could be there? It is human nature to measure the world around us by our own standards. That's why theories about neighboring universes are, to some extent, anthropomorphic. But most likely in these multiple realities, there are completely alien laws and conditions. Doesn't that idea irresistibly stir the imagination? We have just learned about Everett's worlds. They are universes of our clones with different destinies. But it wasn't just the American astrophysicist who speculated on this topic. Andre Linde, another supporter of this theory, believed that universes are fractal, meaning you can even travel through them, although such tourist journeys would inevitably take tens of millions of years. The scientist compares these mysterious worlds to a huge jar in which water exists in different states of matter. One part is ice, another fragment is gas. In the third area, it's ordinary H2O or snow, and so on endlessly. But at the same time, all these worlds belong to the same universe from which they branched off. These aren't the only variations on the theme. There are even more unusual versions. Martin Rees, a professor of cosmology and astrophysics at Cambridge University, suggested in the 1990s that nature creates multiverses as an experiment, as a field for exploration. In general, Rees believed that multiple universes are absolutely barren, since the emergence of life requires a rather strict set of conditions: a narrow temperature range, the presence of water, location in the Goldilocks zone, an old enough star, and other necessary factors. Our world's physical conditions help meet these requirements, but they're unlikely to occur in nearby universes. By the way, Linde also believes that many universes are born dead, with no chance for development, and some collapse immediately after coming into existence. Although, perhaps in other worlds, the cards fell just as favorably as in ours, so the conditions there might be similar. The most controversial but original universes are those of Max Tegmark, a professor at the University of Pennsylvania. The physicist believes that neighboring worlds are a rigid set of mathematical formulas and laws existing outside of time and space. This is the most terrifying and inevitable option, since the laws of algebra make worlds necessary and unchangeable. So if we assume that numerical universes are full of suffering and evil, then it will last practically forever. Isn't that a description of hell?
Есть еще...
An interesting point related to the multiverse, which has repeatedly occurred to everyone interested in this topic. How do you get to a neighboring universe? Does the infamous portal or wormhole exist, which is sometimes called a black hole? Andre Linde also claims that to find the boundary between worlds and cross it, two main conditions are required: longevity and a very large supply of energy. The first is because the distance to the nearest boundary may be 10 to the millionth power light years. The second condition is indispensable due to the immeasurably high energy potential of such a membrane. But if a person does manage to overcome the impassable wall, most likely instant death awaits him. The body will simply disintegrate into particles or radically change its properties, which will also be incompatible with life. Light has surrounded us since ancient times. At night, people of past centuries burned tallow and wax candles indoors, while outside, bonfires blazed and the moon shone. After incandescent lamps appeared, nighttime cities and villages sparkled like Christmas trees. You've probably noticed that nowadays, in many megacities, it's as bright at night as it is during the day. But the evolution of devices that give humanity light hasn't changed its physical properties in any way. The basis of the phenomenon is still specific particles called photons. They transmit all types of radiation, including visible light. Thanks to these particles, we observe distant stars and galaxies, as well as illuminate our homes. To demonstrate the properties of photons, we need to travel into deep space. It is in a vacuum that they truly thrive. Here, particles travel millions and billions of light years, almost without encountering anything. What are the characteristics of photons? They have zero mass and electric charge, have no size, and are capable of moving at the maximum possible speed. In particular, in a vacuum, they travel 300,000 kilometers per second. But in a transparent medium, photons are slower. From the solar core to the corona, it will take the particle about 1 million years. At the same time, it will reach Earth in just 8 minutes once it enters outer space. The photon is the most common particle in the macroscopic world. There are 20 billion photons for every proton or neutron. Time does not exist for them. These particles are practically eternal, but for the photon itself, life lasts only a moment. It lit up and was immediately absorbed. Many people wonder where photons go when a star dies, a galaxy fades, or a light bulb is turned off. For example, the glow of ancient stars, which reached human eyes after billions of years, was emitted when the object still existed, but now it is most likely long dead. But as we know, a star dies slowly and gradually. On the level of an ordinary light bulb, however, everything happens differently. You flip the switch and complete darkness immediately surrounds you. So where do the photons go that the average light fixture emitted just fractions of a millisecond ago? Let's turn to science. The moment an incandescent lamp or any other type is switched on, it starts emitting millions of photons all around. They move chaotically. According to the laws of physics, particles have two options, either to be reflected or to be absorbed by objects. Thanks to the first phenomenon, we are able to see objects around us and observe ourselves in the mirror. It is important to understand that during reflection, that is, when colliding with an object, photons lose part of their energy potential. When absorption occurs, the surface in the field usually heats up.
Энное количество частиц. На практике это проявляется следующим. Теплыми лавочками в летнем парке, горячей галькой на пляже, раскаленными камнями.
Desert. The process that occurs after the lamp is turned on is based on the phenomena listed above. Photon streams are reflected from objects or are absorbed over time.
Когда мы выключаем лампочку, новые фотоны прекращают
to enter the room, and the old ones don't go anywhere. They keep colliding until every particle finds an atom that, roughly speaking, absorbs it. You might have a reasonable question. Why doesn't the light fade gradually, since the remaining quanta are still lingering in the room? If you think about it, the answer will come to you naturally. For photons, any span of time is equivalent to an instant from a human perspective. The thing is, individual particles are reflected and absorbed in millionths of a second. That's why we simply can't catch the exact moment. For the observer, there are only two states, before and after pressing the button. But during this time, the photons go through quite an adventure. But quanta of light surround us not only when we turn on a chandelier or a desk lamp, but literally everywhere. Everyday Wi-Fi, pizza heated in the microwave, radio signals playing in your headphones on the way to work, laser scalpels that help people get rid of terrible diseases, and also powerful gamma-ray bursts capable of sterilizing everything around for many millions of kilometers. This is just a cluster of photons. But if intangible particles lose energy during collisions or prolonged movement, then how does the light from stars and galaxies reach us? And who said that we see all objects without exception? If that were the case, then the night sky would seem bright to us, just like during the day. But it doesn't. Only bodies emitting the most powerful stream of photons are visible to us. Such a beam is capable of traveling across immense distances. As the power decreases, so does the distance at which the light beam completely loses its energy and ceases to be observed. We also cannot see extremely distant cosmic structures because light scatters and photons are lost over vast distances, colliding with planets and other bodies, being absorbed by them, or losing energy. Some scientists have developed an entire theory based on this statement, claiming that the universe is actually stationary, and that expansion is foreign to it. And the Doppler redshift is explained by the effect of photon energy loss, not by their recession velocity. All of this, of course, is debatable and practically unproven, but it has the right to exist. So, the particle that connects the gray everyday life with the cosmos has been discovered. And now, when turning on a light bulb, some of you might try to catch photons literally in the act. But you shouldn't. Frankly, it's a hopeless endeavor. Seriously though, the fact that there are fundamental particles from the boson family is one of the best pieces of news for all of humanity and the universe as a whole. Otherwise, complete darkness would have become the rightful ruler where stars now shine. Just half a century ago, we knew almost nothing about it. Somewhere in the corners of our solar system, an icy giant with a mass 17 times greater than our planet is hiding. His Majesty Neptune, one of the most distant planets in the solar system, which was studied by only one spacecraft, Voyager 2. This gaseous, little studied ice giant has an extremely low surface temperature, down to minus 220 degrees Celsius. Neptune, like Uranus, is classified by specialists as a separate group of intermediate objects located between terrestrial planets and gas giants. It is surrounded by a hydrogen-helium atmosphere, which makes it similar to Jupiter and Saturn. But in addition to these elements, it also contains methane, ammonia, and water ices. As we mentioned earlier, Neptune's mass is 17 times greater than Earth's. But at the same time, it is only about 10% of Jupiter's mass. The equatorial radius is 24,764 kilometers, which is 4 times greater than that of our planet. If a person were there, he would surely get bored. After all, 1 year on Neptune is equal to 165 Earth years. On July 12, 2011, exactly 1 Neptunian year had passed since the planet was discovered in September 1846. Surprised? But that's not all. Seasons on Neptune last about 40 years each, and a day is only about 16 hours long. As for the structure of the giant, it's similar to that of Uranus, but there is one defining difference. A diamond ocean, presumably located at a depth of about 7,000 kilometers in the Neptunian mantle. The conditions in this location are such that methane breaks down into diamond crystals, which fall directly onto the planetary core. There are many celestial bodies like Neptune in the universe. That's why the name of the object is often used as a collective term. The 8th planet, named after the god of the ocean, is located 4.55 billion kilometers from the Sun. That's about 30 times the average distance from Earth to the Sun. How do we know all this? The information came not only from the probe that briefly visited Neptune at the end of the 20th century. Scientific data is also provided by powerful instruments at observatories on Earth. But still, Voyager 2 fully confirmed the saying that it's better to see something once than to hear about it 100 times. The spacecraft flew just 3,000 kilometers above the giant's pole. The spacecraft recorded things that are impossible to notice from the vast distance separating Neptune and Earth. On August 24, 1989, Voyager 2 began its transit past the frozen sphere and sent invaluable images to Earth. In particular, the spacecraft recorded a large dark spot, a titanic anticyclone, similar to the one on Jupiter. It saw Neptune's wispy clouds and epic polar auroras. It flew past its moon Triton, refined data on the magnetosphere and ring structure, and examined 6 more moons in detail. Unfortunately, colonizing a gas giant is theoretically impossible. Neptune itself, due to the lack of a solid surface, is unlikely to be colonized. But its moons are quite a very realistic prospect for settlement. Especially Triton. Thanks to Voyager 2, we know the most about it, although it's still not enough to make epoch-making decisions. Let's start with the fact that flying from Neptune to Triton can be compared to a trip to scorching Egypt, since it's only minus 23 degrees Celsius there. In addition, a unique natural phenomenon called cryovolcanism has been recorded on Triton. Let's take it step by step. What unusual attractions await a person on Triton? On the moon, a tourist can finally stop drifting among the ice and walk on the surface. But you have to do it carefully because the 200-kilometer layer of nitrogen ice is completely covered with cracks that look like the rind of a melon. Under the massive ice cap lies an ocean 150 kilometers deep, made of ammonia, methane, and salts. So you shouldn't count on going fishing. It's unlikely anything survives in this hellish mix. So divers on Triton will also be disappointed. It's a more spectacular sight. These are geysers. In the mind of an ordinary person, they look like small boiling fountains erupting from the depths. Here, a tourist is greeted by a mesmerizing sight. Amidst the frozen, icy desert, suddenly, with a thunderous sound, the nitrogen ice breaks, and a column of liquid shoots up to a height comparable to Everest, with a thickness that can reach 2 kilometers. Triton's atmosphere turns this column into a plume, stretching 150 kilometers. This is nothing like the fountains in Las Vegas. But for now, NASA is only planning the launch of the Neptune orbiter mission, as part of which a spacecraft with 2 atmospheric probes will be sent into the giant's orbit. Before the giant engulfs them in its deadly embrace, the stations will transmit as much valuable information as possible. To reach its destination, the Neptune orbiter spacecraft will perform 2 gravity assists near Venus and Jupiter. The new mission will launch after 2020, and humanity will finally learn details about the mysterious icy body and its moons. Meanwhile, Voyager 2 will continue its journey, and in 3 centuries it will reach the Oort cloud, where it will wander in its dark depths for tens of thousands of years. But that's a topic for another episode, as they say. If you enjoyed the video, be sure to tell your friends about it. And if you want to see more, don't hesitate to click that mouse button and leave lots of likes. After all, your likes and comments are motivation to reach new horizons, which we can reach only thanks to your support, and of course, by subscribing to the channel. So stay tuned.